Well, welcome everyone. We are happy to host the Coney Ag Government Services Emerging Technologies webinar. I'm Paul Williams, Vice President of Solutions at Coney Ag Government Services. And today we're going to dive into multi-domain unmanned systems, the new backbone of government operations. This is going to be part one of our series. We're going to go a little bit deeper on subsequent ones, and we're just excited about this. So in this first session, we're going to focus on an overview of the different domains and how they're used throughout the government, followed up with how the domains can be combined to accomplish more complicated critical government missions. Before I get too far along, let me do a little bit of housekeeping. We're going to keep everyone's cameras and microphones off unless you're actually presenting. At the end of this 30-minute presentation, we're going to allow for some questions and answers. Please post your questions as we are presenting, and we'll get to them during the Q&A session at the last 15 minutes of this presentation. Now let's meet the team. You already know me. Let's introduce you to Val. Val, you want to do a quick intro?
Hey, good morning, everyone. Val Turman here. I'm the CTO of Drone Driver. We build drones from Group 1 to Group 3. Have about 4,000 hours of flying experience, flying drones and other aircraft. I am ex-Navy hospital corpsman. It's great to meet all of you.
Thanks, Val. James?
Hey, good morning. James Fisher, Marine Corps veteran, mechanical engineer, and currently working for Maritime Robotics AS as their senior technical sales and business development manager for U.S. Defense.
Thank you, James. And last but not least, Nelson.
Thanks, Paul. Yeah. Good morning, everyone. Nelson Cantrell, co-founder, Safe Harbor Maritime. We're a service solutions provider for the government commercial space. So yeah, excited to be here.
All right. Thank you. Thank you for joining us today. KGS, our success stems from our people rooted in Alutiiq values. We like honoring our heritage and sharing the catch. So let's move on. Together, we bring decades of experience in deploying unmanned systems for government customers, including DoD and civilian agencies. We're excited to share our insights on how these technologies are becoming the backbone of modern operations. Now let's overview cross-domain unmanned systems. As shown in this diagram, these platforms operate seamlessly across the 5 domains: space domain, aerial domain, ground domain, and surface maritime domain, and subsurface maritime domain. They all interact and perform part of the overall mission with the government. As we go through these slides, I'm going to get our experts in each specific domain to talk about the platforms in each. Moving on to space domain. Many of us are using space domain in our daily lives and may not even know it. It is quickly becoming integrated with our cars, our phones, Starlink for internet service. This growing area has changed connectivity drastically over the past few years. In the near future, there will be hardly anywhere on Earth where you cannot maintain constant connectivity through this domain. Recently, I was surprised to see how much of an ecosystem there was when I was recently at the Space Symposium in Colorado Springs. It's an expansive event with a large variety of vendors offering systems, support, and training. You could literally buy a satellite there. It was a pretty neat experience. Unmanned space systems form the backbone of government operations, offering persistent global ISR, intelligence surveillance and reconnaissance, communications relay, and GPS. Everybody uses GPS all the time, and things like missile warning. They enable multi-domain queuing, like satellite data to drones or USVs, with a focus of proliferated resilient constellations in contested space. There are many thousands of these satellites where the big shift has been moving away from large, expensive implementations that are vulnerable to being taken out by the enemy to many thousands in constellations where if an enemy takes out a few of them, you still have an operational capability. So it's a lot more resilient for the government. For the government, this means cost-effective, resilient assets that support everything from disaster response to national security. Now I'm going to move on to the air domain. For air domain, we're going to let Val cover that with his experience and background.
Hey, thanks a lot, Paul. So in a nutshell, drones are flying robots. They carry cameras, sensors, small computers, and a radio link connected to one of these to fly them. They let people see and act from a distance, safer than sending humans into complicated wartime situations. A basic drone is a flying camera, big 4K camera sitting on the front of this drone that can go almost 10 miles back to someone's goggles who's flying. Modern drones are basically flying sensor platforms. We can put things like AI cameras, LiDAR, and various other sensors that can go out there and make maps, see thermal and heat signatures, track movement, extend communications. They matter because we can take these drones and we can launch them in 20 seconds, even sooner if we have to. We can stay in the air, watch an area, loiter, see what's going on in across the whole spectrum of the battlefield. They cost less than manned aircraft. We can build these for $400 or $500, and we can build them at scale. Back to you, Paul.
Well, let me ask you a couple of questions first. So, what are some of the innovative things that are being done by your company and others to support the scaling of these types of platforms?
Yeah, so the coolest thing that we're working on right now is taking these sensor platforms and building them onto these drones. So you can basically have AI in the sky and do all of the things that we do with AI and LLMs while you're flying dynamic missions. And we've developed technology and a way to manufacture these things at scale. 3,000 to 4,000 or 5,000 drones a month using 3D printers and automation and AI links from our sovereign AI cloud. It's a really cool development.
Yeah, that is pretty neat. The 3D printing really offers a lot of potential at the edge. So that's very cool. And LLMs in the platform is also a very neat idea.
Yeah,
I mean, talk about these days AI. So
yeah, exactly. Very cool. Can you imagine having an AI camera that can do pattern recognition, look for humans, peoples, or any kind of pattern out there? It's really cool to have that capability at hand right now.
Yeah. Val, do you want to cover the groups quickly?
Yeah, sure. So in a nutshell, there's three groups of drones that Drone Driver builds and manufactures. Group 1 through Group 3. So Group 1 and Group 2 are very similar. Group 1 are your standard FPV drones. They are as small as a pico drone like this, a micro drone like this, up to 5 feet. They weigh between 10 grams up to 20 pounds. They're usually run on electric. These big LiPo batteries are running these drones. They're good for quick launch, close range, high tempo missions. For both Group 1 and Group 2, the use cases are reconnaissance, surveillance, route overwatch, communications in degraded environments, perimeter, and security. In the Group 2 area, these are like Group 1, but bigger, and they're like the tactical workforce for many. And they go up to 11.5 feet, up to 55 pounds, carry huge power supplies, and can loiter on site for hours. These can be both a quadcopter like this or a fixed wing aircraft that's using a foil to keep it in the air longer for longer loitering. One of the things in drones that's really complicated is how do I keep these drones in the air for a long period of time? Moving into the last group of drones that we cover are the Group 3 drones. These go up to 1,300 pounds, can have a 20-foot wingspan. These are pretty much autonomous systems that fly at thousands and thousands of miles, and they do wide area intelligence, maritime and coastal surveillance, operational communication networks, and extended border infrastructure monitoring. So these three drone groups represent a big area of capability, and we're proud to develop and build those for you folks. Back to you, Paul.
Yeah, I've seen some really cool use cases where like NASA was using it to inspect power lines on their facilities and things like that too. So it is being adopted quickly. This platform in particular is being adopted quickly throughout the government.
Yep, I agree. I think like the big thing is like, flying fence lines, flying perimeters, and security is super important.
Yeah, it's a great use case for it. Okay, we're going to move on to ground domain. We're just going to touch on it. Unmanned ground vehicles are wheeled, tracked, or legged robotic platforms. They operate autonomously or can be remotely controlled in an operations center. Real-time sensing with cameras, LiDAR, thermal imaging, manipulation with arms and grippers, like they've been used in explosive ordnance disposal for quite some time. But I think the use case that most people are thinking about right this minute are things like Waymo, where you actually have autonomous cars driving you around these metropolitan areas. You don't get a lot of coverage on this type of platform recently, but it's definitely a big part of the military strategy and as well as the civilian government strategy. Now we're going to turn it over to James to talk about surface maritime domain.
Yeah, thanks, Paul. So unmanned surface vehicles, most of you probably know them as USVs or ASVs, are mostly about removing the physical crew or man in the loop from the vessel operation, but not necessarily removing any capability, right? These systems range from, small tactical crafts operating in ports or littoral waters to large, long endurance platforms working offshore and in broad ocean area environments. So the common thread here is persistence and verified levels of autonomy. So what makes USB a powerful tool is not just that they are unmanned, but they are sensor rich and entirely modular. So their standard vessel or your standard vessel would carry, for example, radar, EO, IR, camera sensors, subsea sonars. They'll have AIS, communication relays, or mission-specific payloads. That ultimately you can operate in real time while navigating autonomously, but also in complex maritime traffic or even contested environments. Some levels of autonomy will, based on the maturity, are seeing more edge-based decision making, better resilience in degraded or even GPS denied environments. The early foundations, I would say, of coordinated and multi-vessel operations, which I think most of us know as swarming, that is systematically going to change how fleets think about maritime coverage and overall mission execution. So ultimately, USVs, they're not just a cost-saving tool, right? They reduce risk to personnel. They extend operational reach into hazardous or remote areas, and they act as a true force multiplier for all navies globally.
Yeah,
any
I think
questions,
that
Paul?
some of the value is just literally like as you said, force multiplier. I've seen some government agencies that they just don't have enough platforms to do the work they need done. So this is a cost-effective and rapid capability that they can bring to bear to help them with that, right?
Yes,
How
absolutely.
long how long have you guys been building these platforms, James?
Yeah, so Maritime Robotics, we've been in business since 2005. We're a software first company and then basically built the technology around it. So we have over 300 vessels delivered to customers worldwide. And again, we've been in business since 2005, so a few decades.
Okay, and how long have you been providing autonomous capabilities?
Yeah, I would say the Norwegians are, extremely technical and well-minded people. So I would say, in the last 5 years, the autonomy on our vessels specifically has really matured. And I would say to date, we have some pretty impressive capabilities that, hopefully in a future panel discussion, we can demonstrate for the team here.
Yeah, that'd be fun to see it in action. I guess the other thing I would ask is like, what are your top 3 use cases that you can think of that you're supporting right now?
Yeah, ISR is a big one. Subsea, seafloor mapping, hydrography, bathymetry, that's also a big one. And then logistical support. We have a pretty diverse portfolio of vessels that have they're multi-purpose vehicles. They're not one mission focused or mission centric platforms. You can do 5 to 10 different use cases off each platform. So that's kind of our philosophy: build a boat that can do multiple things instead of building a boat just for one thing. But yeah, those are probably the three primary areas that we see the most traction to date.
Very nice. Well, I'm going to ask you one last question, and the same as what I asked Val. What are you doing to help create the capability to scale it large for the military?
I mean, so one of the biggest challenges, right, at least in the U.S., so I'll just focus there, is our infrastructure to build at scale in the maritime domain. Really since World War II, our ability to build at scale large vessels has diminished. So I think the U.S. government especially has recognized our response to that is building USV platforms of various sizes at scale, leveraging other USV OEMs in this space that can then support the U.S. Navy and other NATO countries. So for maritime robotics, we're building already in Europe, so we have a really great supply chain established, manufacturing, and now we're leveraging strategic partners in the U.S. to help scale and grow here in the U.S.
Awesome. All right. Anything you want to say about the platforms?
Yeah, I mean, just real quick, just a high level example, from again, maritime robotics, we kind of fit into each of these 4 categories. The typical length 0 to 4, 4 to 7, 7 to 15, 15 plus. We have a fully electric propulsion Otter, which falls in the first category, 0 to 4 meters. We say the big brother, the Otter X, falls right between the 4 to 7 meters, again, fully electric propulsion. Then the medium and large vessels are our Mariner X platforms. Those are diesel, Yanmar, Hamilton jet drive propulsion system. But the endurance, payload capacities, and your primary missions, to Paul's question previously, this is what we're typically experiencing customer demand signals are. Excuse me. So endurance is a factor, payload capacity, and then
I think we might be losing you, James. Oh, can you hear me okay?
Yeah.
All right. One last question. What's the most interesting way you've delivered one of these platforms to the mission area?
Well, we actually are the only to date USV manufacturer with vehicles in Antarctica. So that's probably one of the most challenging logistical feats we've experienced, just because of, for obvious reasons, getting into one of the most not hostile, but challenging environments probably in the globe. Getting our vehicles to that region was a hurdle. But we actually have 2 of our Mariner platforms and are delivering a 3rd Mariner X, which is our 9-meter vessel, to an Antarctic company that fishes for krill, actually. So very fascinating program. Have some literature and videos to share if anyone's interested.
All right. Thanks for sharing that with us. Okay. This is meant to be an overview, so we're going quite quick, but we will have some more in-depth sessions following this, as I mentioned before. James, you want to take subsurface as well?
Yeah, so unmanned underwater vehicles, again, probably most of us know them as UUVs or AUVs. They extend the autonomy below surface. They range from small manned portable systems to large, long endurance platforms that are usually capable of deep and persistent subsurface missions. So these systems can be deployed from offshore support vehicles or OSVs, submarines, and again shore to operate in some of the most unforgiving environments. Right. What makes the UUVs necessary is their ability to sense and operate in GPS denied environments, high pressure, low visibility conditions. And they rely on advanced sonar, environmental sensors, autonomous navigation, not only to map but inspect and monitor underwater terrain and infrastructure. So, similar to the USVs that I just spoke on, they're becoming more intelligent, more modular. They're capable of carrying specialized payloads and integrating with surface and air systems. So the real, in my opinion, value here is the persistent subsurface access with reduced risk to divers, for example, and significantly lower cost compared to manned and submersibles, especially in deep or hazardous areas. So tying in what Val discussed with UAVs, what I just previously discussed with the USVs, and now UUVs, you'll see in the upcoming slides as Nelson um, communicates how the multi-domain factor is now in play and all these subsystems can work together.
Very cool.
Yeah. Any questions with that, Paul? Yeah, I mean, again, another high level chart just to kind of give you. And now, again, this is not meant to be all encompassing. It's a high level just review of some of the systems out there. There's many more, but similar to USVs and UAVs, even you're always going to focus on your weight, your endurance, right, and your primary mission capabilities. So understanding your customer, what the market demand signals are, what's being asked of us, we can then help develop these systems and deliver a true capability that's in demand today.
Mute. You're on mute.
You're on mute, Paul.
Apologize. James, I've heard a lot more about the UUVs than I have USVs until recently. So I know that I have seen the UUVs in use for well more than a decade, but it seems like the popularity or the people are starting to explore the USV in concert with UUV a lot more these days.
Yeah, that's an interesting perspective. I've primarily been involved, excuse me, in the USV space. I do have I'll say a solid foundation on the UUV space, but I would say both technologies are definitely advancing rapidly. And I think as we explore that multi-domain capability, you're going to see, all three, system level autonomy, working collaboratively in probably some pretty hostile environments for the U.S. government and military.
All right, thank you. And that leads right into multi-domain mission. And Nelson's going to cover this for us.
Yeah, thanks, Paul. And it's a lot to cover. Multi-domain, collaborative autonomy, these are all, major buzzwords, we see in the space right now. And, it's an exciting topic for all of us. I mean, I could talk about this for hours. We have to kind of condense it for this webinar, but there'll be future ones here soon. So for today, I kind of want to just share some specific insights kind of we've gained as a service and solution provider who has, been in the field, working alongside some of these emerging technology companies and, the government organizations actively trying to adopt them. One of the major efforts we supported was the Replicator and Overmatch initiatives last year. And that was an environment that, brought together multiple vendors, USVs, UAVs, collaborative autonomy providers, alongside DIU and Navy stakeholders. And they're all working toward a multi-domain swarm defense capability for the US Navy. And what really came out of that effort and others like it was there's a shift the way the government needs to do procurement and puts this capability out into the field. And we're seeing with admirals and leaders within PAU RAS, that's these new government groups that have come under this new admin. They're saying they don't want to buy hardware. They don't want to buy hardware. They want to buy capability, and they want to buy it at scale. And so these can't be isolated systems. They can't be standalone software. It needs to be integrated mission ready outcomes that can be delivered quickly at pace with our adversary technology. And so to do that, they need the ability to procure from multiple vendors with no vendor lock, open architecture, modularity, systems that can be integrated, adapted, and scaled across multiple mission sets. And increasingly, they're relying on private industry to assemble and deliver those capabilities for real world deployment. If you want to go to the next slide, Paul. For example, so in this slide, this is just going to give you very high level, but to really package a full multi-dome capability, everything's gonna have to be able to integrate it in the data, and everything's gonna be seamless into one, remote operational picture, whether that's, could be at a military base or a large vessel out there that's put out a swarm capability, for example. And all of that stuff is going to be needed to combine into this, seamless operational picture. And then the logistics about deploying all these different types of systems and the data processing, it's a huge overhaul for like the US government, for example, to build out internally and do that quickly. So you're seeing an insurgence of the private industry, taking on a lot of this, packaging and providing capabilities that look at all three domains and combining them in a mission capability. If you want to go to the next slide, Paul.
Yeah, before we move on, I just want to ask a question real quick. How interoperable are the systems right now? If you had to put a percentage on it, like of the systems you get out there, how many of them can you plug and play with different systems?
Well, it really comes down to the companies that are willing to work together. So, like Maritime Robotics, for example, is a great partner to us. And what's so great about their platforms is that they are very interoperable. You can combine different types of platforms. They've been integrated with a lot of the censored sonar, different payloads that are out in the market, and they're open architecture. They're willing to do that, that level of integration, that engineering that needs to be behind the scenes. And so we're seeing across the industry, more and more people are starting to work together. I mean, if you look at those Overmatch and Replicator, I mean, you had vendors from Saronic, MapC, Anduril, L3, all collaborating to try to build out a capability that the Navy can go ahead and go deploy. This is public information, but that was really targeted at defending Taiwan in case of a Chinese invasion. So I would say it's probably getting in the 90%. I mean, I think most platforms out there are willing to, open up their stack and let companies integrate.
Oh, that's great. Good to hear.
Yeah. Yeah, and so us at Safe Harbor, we're actively kind of building toward providing capabilities that combine multi-domain. And this is a brief example of a port security architecture that we presented to Homeland Security and FBI and Coast Guard here in San Diego last year. And in this kind of operational concept, you see a layered multi-domain integration. So there's different classes of USVs with cameras, infrared, thermal. You have LiDAR, radar, and AIS, and each optimized for specific roles inside the port or in near coastal approaches. And you'd combine that with static surface and subsea sensors positioned at certain areas in the port or at the entrance, and then you have the option to add, UAS, UAV, or tethered systems to two UAVs or two USVs for persistent overwatch. And what we're doing with this is we're saying, hey, we Maritime Robotics as a partner, we can actually combine all of these different layers and put it into a remote command center, into a clear operational picture for the government or for a commercial customer or port authority. And this is just one example. The multi-domain model applies to ISR, swarm defense, infrastructure monitoring, hydrographic survey, and beyond. And really, all these missions require experts and technology from a variety of providers. And they all need to be able to collaborate. They all need to not compete in silos to really deliver that capability. And I think that's what's so exciting about it. That's why we kind of have this panel today. It's we got Cognac, Drone Driver, Maritime Robotics, and us at Safe Harbor, representing different pieces of the ecosystem and working together to really deliver a multi-domain capability to the government. So exciting stuff.
I think that is very well said. What are some of the biggest challenges that you're seeing right now for adoption? Is it training?
Yeah, I mean, yeah, it's a great question, and we are building out training for uncrewed maritime systems, through Safe Harbor Maritime, but that really ties it all together because autonomous functions. When you talk about who's going to be orchestrating this multi-domain capability, it's going to be a very highly skilled operator that's going to be remoting into different platforms and is going to have to put systems into autonomous mission modes and take them out of it and plan missions and all that. So the training behind it, and that's why I think there's going to be more and more solicitations. We're actually seeing it where they're relying on private industry, where they actually just want companies to work together, deliver a capability, and maybe they're the ones actually operating because the training that goes behind these type of missions using multi-domain, it's gonna require some pretty hardcore training, and I think the government and the commercial side are all seeing that.
And do you, for your training, do you see people be more successful if they have experience with the subject matter, like maritime, like someone that's operated boats? Are they better with the USVs, or is it better to have someone that's just kind of blank slate and just learn the platform?
Yeah, I mean that's great question. I mean, so us at Safe Harbor Maritime, we're all 100-ton captains. We're maritime professionals that started this company, and there is a there that background is what we when we come to our maritime courses is we give those basics that you need at coal regs as a mariner. You really need to understand those principles, and then you layer that in on the USV, the operations using a GUI, setting missions, autonomous functions. But you need those core principles to really, be a USV operator, or operate these systems in maritime. So, yeah, 100%, Paul.
All right, great. Well, everybody's done a great job of giving us an explanation of all the domains and how it supports the government. As promised, we're going to jump into Q&A. So now let's just go through some of the questions. The first question, Val, I want you to answer this one. How long does it take to build Group 1, 2, and 3 drones?
So to build a by scrap, by hand at home, that kind of thing, and develop a prototype takes maybe 3 to 4 days if you have solid requirements. Once you have that prototype built out and you know what you're building, we can mass produce these things really fast. We can take a drone like this and put 5,000-6,000 of these out in a month and deliver them ready to go for your mission. It's pretty straightforward, but the hard part is basically getting everything to work, all the sensors to talk to the Raspberry Pi and the onboard compute and all that, and that's what we specialize here at Drone Driver. So yeah, it's pretty quick.
Okay, that's pretty impressive. I wouldn't want to be on the other side of that. So the second question is about, are most of these things done from a skiff? And James, I'm gonna throw this one at you if you don't mind.
Yeah. I would say to date, no. The answer is no. I think eventually, as these systems continue to develop, AI becomes more prominent. The multi-domain, as Nelson mentioned, becomes more of a strategic use case. There will be teams sitting in skiffs and a 10, 20, 40-foot connex in the middle of the desert somewhere, probably operating these platforms globally to support different military initiatives. You kind of see it or have seen it, right, with UAVs in the Iraq and Afghanistan wars. I mean, what I think probably the U.S. Air Force sitting in connexes operating Reaper and other very large, sophisticated drone technologies from Arizona, right? But the drones in Iraq.
Right.
So, in my opinion, yeah, to answer your question, yes, I think that is the future. But as of right now, I think the technology still is somewhat new / emerging, at least in the U.S. In the NATO countries, it's not typically a skiff level environment for these operators.
Yeah, I'd say the things that do happen in the skiff is like the mission planning and the data analysis and some of those things that the secret, when the secret sauce is put on it, right?
Yeah, and I will say, so our company actually has some vehicles in Ukraine. I can't get the specifics on this, the mission profiles, but even those vessels are being operated, there's outside, right, at a local remote operating center, yeah, on class environment. So, but yeah, I do think the future looks more classified, certainly.
Okay, awesome, thank you. This one is for Val.
Yep.
What is your opinion on an unmanned medical evacuation and medical resupply taking off in the future?
Yeah, so I take that pretty personal because I was a hospital corpsman in combat situations in the Middle East, and having the ability to get things you need on site really quick, like blood, plasma, battle dressings, is super, super critical. And having the ability to possibly medevac a person out with a drone instead of waiting for a helicopter is something that I see coming very, very soon. And you can do it at scale with many people getting moved in and out, moving lots of different supplies in and out. I see that as an imperative for the future, especially in the austere environments like Afghanistan and stuff like that.
Yeah, I'm hearing a lot of these kind of conversations in the medical community as well. So I think it's definitely in the future.
Yep, 100. I agree.
So next question is, are we aware of an Army initiative named Sky Foundry? And I'll leave that to the panel.
I responded in chat, but
Oh, okay.
yeah.
I didn't. Oh, yeah, familiar. Yes. Okay.
Familiar with it, yeah.
Okay. So Mark Music is asking about, do we procure or manufacture batteries for these systems?
Yeah, so we mostly are procuring batteries like these big 8,000 milliamp batteries. But what we do when we get them is that these things are all soldered together in this big block format. We take them all apart and make it so they fit onto the drone in a more aerodynamic fashion so that we can put all the sensors and gear on there. So we don't really have the ability to make these things yet, but we are procuring them and try to keep a lot of these on hand because this is a pretty important part of the whole package.
I love that you just had that battery ready to show for that question. So,
and it's cool because you got like small drone batteries and you got big drone batteries, and you can add multiple battery packs like this to get more and more endurance. But weight, cost power, cost money, cost time on station.
Yeah. Hey, I'm just gonna tell you there was a question about, can you have the recording? This is going to be recorded. This is going to be put on YouTube. So very easy to get afterwards. Eleanor will get it out there. Eleanor and Joe will get it out in the next couple of days at the latest. And you should be able to view it as much as you want. Joni asks, are there any solar powered or backup powered?
Yeah, one of the things that go ahead, sir. Oh, James.
That's for which platforms?
Yeah.
Oh, she didn't specify. So if you've got something to add to it, just throw it in.
All right, go ahead, Bill.
Yeah. So on a drone, the amp pull on these drones is pretty significant. So having a solar on a quad like this would be a little bit difficult. On a bigger, class 3 drone, we can skim the wings with solar panels and to drive like some of the subordinate systems on the drone to ensure that we keep more power available for the endurance of the mission. We have used solar for recharging batteries in remote areas where we don't have power. These things require a lot of power, and it takes a long time to charge these things. So having the ability to power them by solar is important, but not there yet. But we can charge batteries with solar.
Yeah. What about the I've seen like do they call them vampire drones, where they actually attach to the power lines and recharge themselves?
Yeah. So picture a drone like this, and it has like a V on the bottom, and it basically perches on top of a power line, and it has a series of resistors on the bottom of the drone that basically pull the power through the insulating factors on the wire and use that as a charging mechanism. It's a little risky, landing on a 50,000 watt wire, but if you need to do it, you need to do it.
Yeah. Well, I mean, I think it's kind of neat. It just gets tired and it goes and takes a rest on the power line, and now it's good to go again.
Yeah. Another cool aspect too is that you can take these drones and you can just land them out somewhere and perch them somewhere and do reconnaissance as it's sitting static and then fly it home. So a lot of different capabilities that you can do with these things.
Right. Hey, James, do you want to talk about it from the bigger platform perspective?
Yeah, I mean, across the industry, there are several USB OEMs that have vessels with solar powered or solar panels already embedded in their hull form factor in some capacity. My company has actually chosen the approach that we're payload agnostic, and we have large vehicles that can integrate solar panels if required. And we have the design and development, already in place to do so. Some customers love it, some customers don't necessarily need it. So, just our philosophy is, if the customer wants it, we can provide it. If they don't have to buy it, right? So I think most USB companies are providing some level of solar powered technology. They trickle charge. Most of them have BMSs, battery management systems, and depending on your battery chemistries, that all kind of factors into the size of the solar panel required to keep your vessels on the station for long endurance periods.
And how fast
from
and how
solar,
powerful.
Right, your power density is critical, right? I mean, that's sure for drones, it's the same. They're even smaller, and obviously they want to fly, right? Boats float in the water, but we're always concerned about weight. There are still, some limitations to, how much payload you could. So, I've worked with, battery companies that can build, bespoke battery solutions with custom BMS, integrations. So it really just depends on, how things are moving or progressing, and what the manufacturers want to do.
I think we have time for one more question, and then we have to close up. And Micah asked, what are the lead times on batteries, and are you experiencing any kind of lead time or issues with delivery based on PCBs and batteries? So that's probably for Val.
Yeah. Think about it, right? If you have an order from the DoD for 100,000 drones, that actually means you need 100,000 of these to fly them, and maybe some backups to ensure that they all work, and to charge all these things up. So you need a battery strategy to keep these things flying. It takes a bit of time to plan out, especially at the scale that DoD wants them to get these batteries on site and working. So that is a challenge. I think we're starting to build batteries in the United States, so that should fix that problem very shortly.
Great. Well, I want to thank everyone, especially our team members, for doing this. I just want to remind everyone, we are going to get a demonstration, so keep an eye out for the announcement on the next episode of this series. We're going to talk about C2 systems, mission-specific use cases. We'll have some additional panelists as we go. But meanwhile, I want to thank everyone that showed up to the audience, but I also want to give a special thanks to our experts on the panel. Nelson, your company provides great service to the government. Anytime you need training on USV or other drone type activities, reach out to Nelson, as well as the C2 and operations. And then Val, same thing from the unmanned aerial systems. They have a training program. We didn't get to it during the demo, but it's also really awesome. And then James has got one of the greatest platforms for unmanned surface vehicles out there. So reach out to any of these guys with your needs, or if you want to collaborate on business, we'd love to see them grow. And with that, we'll see you on the next one. Thanks, everyone.